And let's minimize that. And we are mostly good to start. Okay. Oh, and I just did the old man thing again, where I tried to click on the close icon on my phone with my mouse, but it turns out you can't just use your mouse to, just because the phone is next to the screen, does not mean I can move my mouse from one to the other. That's not how that works. I think the weirdest like juxtaposition of technology that I ever did was when I was doing my PhD and my dissertation. I was writing in writing and correcting my work a lot, typing a lot, and I was away from my computer and I had a stack of papers that was ordered in a certain way, and I looked at one and then put it back, but realized by putting it back on top, I had messed up the order of everything. And without even thinking of it, my muscle memory, my left hand reached out like this. And I realized it was because I was reaching to hit Control Z to undo what I had just done, because my brain had taught myself, uh-oh, you made a mistake. You should undo that with Control Z as soon as you can. But it turns out Control Z doesn't work in the real world, at least not yet. It would be handy if it did. All right. So it is, what is it? It's Monday the 22nd, and it has been a special series of days for everyone. Apologies to any of you who were dealing with the cat card issues this weekend. Be curious to hear in the end who had the bright idea that just canceling all you guys' cards. I mean, who would have thought that during a pandemic, when 99% of what we're doing is on Teams and computers, that would have any impact on anyone? Hey, by the way, Zena, I don't know if you know your mic's on, just FYI. But we are here and we are making it work. And then on top of it, then they dumped some snow on you guys to try to slow you down as well. But I know you guys love Math 356 far too much to be deterred. So I am happy and impressed that all of you guys are here. Hopefully you saw my message and Captain Forbes' message. We both doubled up on it, apparently. That the Lab 7 is extended 48 hours. But as a reminder, I'm trying to make it clear in there, extending the lab due date for some of you guys who had connection issues or for where the solutions we had this weekend didn't work out. But that does not mean I am just pushing the entire course 48 hours to the right. So everything else still stands, including the GR that we have this Wednesday, which I say Wednesday, but as always, I mean that it opens up at 7 a.m. on Wednesday. And so you have any time from 7 a.m. Wednesday until 1700 on Thursday to do the GR. So it is incumbent upon you guys to figure out how you want to balance that time with your lab and your GR to make sure you get both of those things done. Also, we still have a EI blackout during the GR. So that people are not it'd be like having, if we were online, of saying you could do EI while we were doing a test in the classroom. That said, hopefully you guys also saw the message that because I had a bunch of people scheduling EI today, but then the schedule calls threw that all off and everyone was trying to reset for later. So rather than trying to accommodate all those at different times, I just set up a 3-hour EI session for this afternoon that I invited all of you guys to. So it is not mandatory, but I am going to think of it as like a virtual open office hours that I'm going to be sitting in the meeting from 1:30 until 4:30. And then anyone is welcome to join and leave anytime during that. So there'll be probably sets of time where I'm just sitting there by myself. I will mute my microphone until someone comes in. There will be sometimes when it's just me and one other person, or sometimes there might be a group. But just think of it as me sitting in the classroom, available for any EI questions that you guys have during that time. I think it's the best and frankly only way I'm going to accommodate all the EI requests for today. And tomorrow I will try to stick to actual scheduling things a little bit better, assuming we don't get another 8 feet of snow dropped on us overnight. Okay, I think that is all of the main points that I got going on. Does anyone have any other questions before we get into today? Okay, so as I implied earlier, today is our review day because we have our GR on Wednesday, Thursday. Normally I would be collecting questions over the weekend, but I think also from a lot of people being locked out, it reduced the number of questions. So if anyone has any questions that they have today that they brought either specifically from the homework or from the labs or from the book or from any of the practice exams, as I said before, if you brought them today, I am happy to work through any of those or answer any general questions. We did that more in section 1. Section 2 opted instead, they did not bring as many questions, but instead we jumped over onto the practice GR2 that is currently being shared on Blackboard and kind of used that as our outline for working through today and kind of sparking questions and going in deep there. So I'll leave it up to you guys. Does anyone have any questions that they would like to hit on first? And if not, then I will jump over to the practice GR from last semester until someone has something that they would like to ask about.
Sir, for the lab, the hypothesis test that it's talking about running in particular for like, because it talks about like the average of the core and majors GPAs, it's wanting a difference or difference of means hypothesis test. Is that correct?
Correct. I'm sorry. I'm trying to open my coffee here without dying on camera because it is far too hot and I am a baby. I don't want you guys to see me scream like a child on camera. Yes, it is a, that is definitely a difference of mean, right? Which you can, and that's a good practice for GR type questions of being able to read the question and understand what kind of question it is asking, right? Because, I'm sorry. I just realized we are talking about different things. You're talking about lab 7 or lab 6?
Lab 7.
Okay, so lab 7. Let me, excuse me. I was just talking to someone about lab 6, and so that was what was on my head. So you are talking about lab 7. Which question?
I believe it was both of them were difference of means. The very last one, question 9.
So question 9 says, so question 9 is a, so I'm glad I looked up because question 9, not a difference of means. It is a mean of differences, right? Because question 9 says, conduct a hypothesis to test whether or not on average, major GPAs are higher than core GPAs, right? So if this was a difference of means, it would be saying the question would be phrased slightly differently, right? So if it was a difference of means, the question would be, is the mean major GPA higher than the mean core GPA? Because then you have two means and you are comparing, is there a difference between those two means? But what the question says is, it says, on average, are major GPAs higher than core GPAs? So it is a single average. It is asking about the mean difference between those, right? And so you can, when you do a mean difference, that is paired data. You can do paired data here because each observation is a cadet, and so we can pair the data of looking at one cadet's major GPA and that same cadet's core GPA and say, what is the difference between them? And then find that difference for every single cadet and then say, what is the average difference, right? So this is what we talked a little bit about last week of saying, what is the difference between the mean of differences instead of the difference of means? And so since we here are talking about a single average, then we are talking about the mean of the differences. I realized I used the words mean and difference a lot there. Were you able to follow that, or did you get lost?
I think I got lost. So with like a difference of means, you take the original data set and you subtract those values from one another, and then take the mean of that.
So let me take a step back here. When you're doing a difference of means, you have two different populations. Each one has their own mean. So if I wanted to say, is the mean GPA at USAFA the same as the mean GPA at West Point? Those are two populations, and I'm looking at the same variable, but I am looking at saying, is the mean in one population different from the mean of a different population? And the way I do that is I take a sample from each population that might be a different size, and I calculate a sample mean for USAFA and a sample mean for the West Point, and then I compare, is there a difference between them, and run a hypothesis test, and I end up with saying the mean at USAFA is different than the mean at West Point, or I don't reject it. On the other hand, the mean of the differences is when I take I usually take a single type of population and say I look at paired data, and so I have a single sample size because I am pairing either like someone's heart rate before and after they ran, or in this case, I'm taking someone and I'm looking at their core GPA and their major GPA, and then I'm taking a sample of however many people. So I'm saying, and then I am curious of saying, is the average increase in heart rate for people 2.5 beats per minute, right? And I take a sample of 100 people, and for each of those people, I see what is their heart rate difference, and then I take the average of all those differences, and now I have a single mean. It is the mean of the difference in heart rate. In this case, I am looking at everyone's core and major GPA and saying, for each person, what is the difference between their major and core? And then I take all of those and get a single average, a single mean of the differences. I only have one sample size because I've got core and major GPA, but I have the same sample of cadets. And so I have a core and major for each cadet. And then I have I find a difference for each one. And so I have whatever my sample size is, I have that many differences, and I average all of those, and that is my estimate of the average difference. And so then at the end of the day, I can say, hey, my null hypothesis was that the average difference is 0, meaning your core and your major GPA are the same, versus an alternative, which would be something like my average difference is greater than 0, meaning that on average, your core GPA is higher, that you have your core GPA is higher than your major GPA. Is that better, or am I still going down the wrong path?
I think that clears it up a lot. So where question 9 would be like our paired t-test, where we are looking at that one sample of data of the heart rates before and after, whereas question 4 would be a difference of means, because we're looking at two different population groups. We're looking at the mean GPAs of STEM and the mean GPAs of non-STEM people.
Exactly right. Yes, you're right. Question 4 would be a great example of a difference of means, because yes, you're doing the mean of the stems minus the mean of the non-stems. Exactly right.
Yes, that clears up a lot. Thank you, sir.
Definitely. All right, that was a great question. Anyone else have anything that they want to hit on, or as a compromise, because this came up last period, if we do move over to the practice GR, if there is a particular type of question you would like to see, there's 28 questions in that practice exam. Odds are good that I could find, assuming it's a type of question that we would ask on a GR, that you could find an example of something on there. Not everything, but a lot of things.
Sir, I have a question, or, well, I guess it's like more of a request. Could we go over, like, because I feel like we did a lot of different tests this block and it's kind of hard to keep them straight. Like, would it be possible to kind of like quickly go over?
Oh, sure. Yeah. We can zoom up to the 10,000 foot level. All right, give me a second. I think I have open. I got to be careful. I've got a lot of GR stuff open right now, and I am doing my best to not share a screen suddenly that says all of these solutions to the GR. I know you guys are less concerned about that, but it would be annoying for me. Okay, so in theory, are you guys seeing my Excel screen now?
Yes, sir.
Okay, so this is our course outline, which I highly recommend if you're looking for a place to start. This is a good summary of our lessons and what chapters they were from. And then if you want to go into more detail, then look at the guided lessons and you can see what the lesson objectives were. So I'm going to give maybe, and please interrupt me if you got a question or if I'm taking too long. I'm going to try to give a 10-minute or so, like kind of top-down version of what we've done. So this is everything we did this block for statistical inference, right? And so almost everything here was either a hypothesis test or a confidence interval, right? It was basically just a bunch of different things. So we started out talking about how we were going to do it. Then we talked about what they were. And then we gave a bunch of different examples of saying, if you're in this scenario, then we use this hypothesis. Here's how we do the hypothesis test, right? Because in each case, when we do a hypothesis test, every hypothesis test starts and ends the same way. Every hypothesis test starts with a null, an alternative, and an alpha. And then we do, depending on the scenario, we execute differently, but then we always end with a p-value that we compare to our alpha. And if the p-value is smaller than alpha, we reject our null hypothesis. If the p-value is greater than our alpha, then we fail to reject our null hypothesis. I just realized I was staring into the camera that you guys aren't actually looking at. All right, so we started in lessons 14 and 15. That was just mostly laying the groundwork, right? So that is the type of thing you might see conceptual questions on, because we started off saying, what is a estimate? And we talked about what's the difference between a real parameter and how we estimate it from a sample. And we talked about how when you take different samples, you're going to get different estimates. And that one doesn't make the estimates wrong. It's just that there is a certain amount of variations in those estimates, right? And then we said in lesson 15, we went on to explain the central limit theorem of saying, however, if we were to keep taking estimates forever, we can start to see that the probability of getting different estimates are distributed in a predictable way. And we said that is the foundation of why we get to do everything we do for the rest of the semester, because when I get an estimate, I can now calculate what the probability of getting that estimate was. That's what a p-value is, right? And so the rest of the block was predicated on this idea that I'm going to take one estimate, and then I'm going to look at it. And then when I do a hypothesis test and find the p-value is basically just saying, what was the probability that I would have gotten this estimate if the null hypothesis was true? If it's small, then we reject the null hypothesis and say, hey, the probability is so small that I don't think that was true. If the p-value is high, that means there's a high probability of getting this, and therefore I can't reject it. So that was 14 and 15. It was the foundations. The rest of the lessons were doing confidence intervals and hypothesis tests, and they were just divided into what types of scenario. So lessons 16, 17, and 18, those were all about doing confidence intervals or hypothesis tests for proportions, right? So these were situations where where I wanted to know things about I had a categorical variable, something like gender, that could be male, female, or ethnicity, that could be, let's say, I don't know why I suddenly forgot ethnicity, Caucasian, African American, Latino, things like that, right? And then we said, take one of those values and say, talk about the proportion. What proportion of Academy of the cadets are female? What proportion of the United States is African American, right? And so when we were looking at proportions, we said, okay, then for anything with proportions, we are going to use the normal distribution to calculate Z statistics and find our p-value, right? And so it was just 3 different types of proportion tests. Or I'm sorry, 2 really. The first one, this is where we broke up confidence intervals. So for confidence intervals, we said, what if we don't know what the actual proportion is? And we said, we can take a sample, use that sample to make an estimate, and then we can build a confidence interval around it and say, I am 95 or 99 or whatever % confident that the real parameter is somewhere in that range. Then we talked about the hypothesis test and said, well, I can do a hypothesis test for a proportion. And that is where I say, hey, I think that the real proportion of women at the Academy is 30%. And the alternative is that it is greater than 30%. And we did the test then to take a sample, get an estimate, use that estimate to calculate a Z-score. So our test statistic was a Z-score. And then we used that Z-score with P-norm to find the P-value. And that's what we used to decide whether our null should be rejected or not. The difference of proportions was the same idea, but now we were taking 2 different proportions, right? So from 2 different populations. So saying, instead of saying, is the proportion of women at the Academy 30%, we said, I don't care what it is. I just care, is it different than the proportion of women at, let's say, West Point, right? So my null hypothesis was that proportion of women at the Academy minus proportion of women at West Point is 0. And then my alternative was either greater than 0, less than 0, or not equal, depending on what I wanted to prove. We did everything the same way we did for a proportion of a test for a single proportion, where we used we got a Z statistic and a normal distribution. The only differences was that now we had to calculate p hat pooled in order to find our standard error, and our estimate is no longer a proportion, it's the difference of proportion. So whereas in 17, our estimate was proportion of women at the Academy, in 18, our estimate was proportion of women at the Academy minus proportion of women at West Point. It was that difference. That was the thing we cared about. So that was 16, 17, and 18, all related because we were doing proportions, and that required us to use a Z statistic, Z test statistic in a normal distribution to find our p-value. In lessons 19 and 20, we moved from talking about proportions into talking about distributions, right? So we again looked at a categorical variable like ethnicity, but rather than saying, what is the proportion of African Americans, or is the proportion of Latino here different than the proportion of Latino somewhere else? Instead, what we said is, how are all of those categories distributed, right? And so in lesson 19, we said, hey, let's look at how all those categories are distributed and say, are they distributed the same as they are somewhere else? So we might say things like, is ethnicity at the Academy distributed the same way it is in the entire United States, right? And so the way we did that was we looked at how many of each category we had at the academy, how many Caucasian, how many African American, how many Latino, and so on. Sorry, there's a fire truck going on outside. And then we said, what did we expect to see? Meaning, if, I don't know what the actual percentages are, but let's say that the 15% of the United States is Latino. Well, then if our distribution matched the distribution of race in the, I keep going back and forth between ethnicity and race, I'm sorry. In the United States, we would have expected 15% of all cadets to be Latino. So since there are about, let's say there's 4,000 cadets, that means I would have expected 600 cadets. So I look at my actual number and my expected number, and I do that for all categories, and I use that to calculate instead of a Z test statistic, now we use that to calculate a chi-squared test statistic. And because we're using a chi-squared test statistic, instead of comparing it to a normal distribution, we compare it to a chi-squared distribution. And so that's how we find our p-value. Instead of using p-norm, we now use p-chi-sq. And for the chi-squared, because it is squared, it is always positive. And so we always do the upper tail to find our p-value. Lesson 20 was very similar. It was using a chi-squared test statistic and the distribution to find it again. But now, instead of saying, instead of looking at a single variable, we looked at two variables. So instead of looking at just ethnicity, we might look at ethnicity and your choice of major. And we are now asking, does your choice of major have anything to do, or is it dependent on your ethnicity, right? And so we would have this table of saying all ethnicity values here and all major values here, and then account for every combination. And it's similar to 19 because we are saying before 19, we said to do our test, we said our race is distributed here the same way they are in this other population. Here, we are saying, are these combinations distributed the same way as they would be if they are independent? So for each value, let's say I look at the number of Latinos who are English or let's say math majors. If I look at the number of Latinos who are math majors, I have the actual number at USAFA, but then I calculate what would I expect if they were independent, meaning if there was no relation, then I should see what are the total percent of people that are math majors, and that should be the same percent of Latinos who are math majors if they really don't have anything to do with each other. And so that's how I calculate all my expected values. And just like I did in lesson 19, I find my chi-squared test statistic, and then I use that with the p-chi-sq to get my p-value and decide whether or not I reject my null hypothesis. So going back 16 through 18, these were all about proportions, and we had to calculate a Z statistic and then use the Z statistic against the normal distribution with p-norm to get our p-value. In lessons 19 and 20, we were setting up something, we were talking about how things are distributed, whether among the variables, and we use that to calculate a chi-squared test statistic and then use p-chi-sq to find the upper tail of that test statistic to calculate our p-value. And then in lessons 21 through 23, we moved on to the new concept of saying, what if instead of a categorical variable, meaning something like gender that can be male or female, or something like ethnicity that could be African American, Caucasian, Asian, Latino, Native American, something like that. What if we wanted to do a test about a numerical variable, something like age or GPA or the time it takes to run a mile and a half, right? These are all things that just have a numerical value, right? And so in lessons 21 through 23, we talked about hypothesis tests for the about the averages of a numerical variable. And so for all of these, we said, hey, we now need to use a t distribution. So everything we did in these lessons was to get a t-test statistic, a t-score, instead of a z-score or a chi-squared. Here we got a t-score, and then we use that on a t-distribution with pt to then find our p-value, right? And these were slightly different. So in 21, we said, what if I have a population and I'm just checking a single average? So this would be questions like, this would be null hypotheses like average age in the United States is 41.2, or average GPA at the academy is 3.1, right? It is a single mean, and I am saying it is equal to this thing, or it is greater than, less than, or not equal, right? And so in that case, we took a single sample, got a single estimate, and then used that to calculate a single p-value to decide whether or not we rejected our null hypothesis. In lesson 22, we said it was almost the same as 21, but this goes back to what I think Ryan was just talking about, of saying we have paired data. So it's really a single set of data, but for each observation, we have two numbers, whether it be for each cadet, what their core and their major GPA is. Or I think in class we did the example of, I took a group of people and for each one of them I said, what was their heart rate before drinking coffee and after drinking coffee? But whatever I do, I have one set of paired data, and for each pair I find the difference. And so at the end, it is the same as 21 because I have a single set of differences, and then I am just curious, what is the mean of those differences? The differences are now my single variable. So just like in 21, where we said, I think average cadet height is 72.1 inches, in 22, I would say something like, I think the average heart rate, the average difference in heart rate is 0, or I think the average difference in between core and major GPA is 0, right? And so I take all those differences and I find I do a hypothesis test on the average, and I do it exactly the same way as 21. I get a t-score test statistic, and I use that with pt to find my p-value. I just have to decide, unlike chi-squared, which is always upper tail, for these, just like when we did the proportions, my alternative hypothesis is going to decide whether or not I want to do a lower tail, upper tail, or both tail, right? In the question of the heart rate, it would depend, is my alternative hypothesis that heart rate, the average difference in heart rate is negative, positive, or simply not 0? Do I think your heart rate's going to go up, down, or stay the same on average, right? And then the last one is the difference of two means, right? This is where I am comparing the means of two populations. I no longer care, is the average height 72.1 inches? I am now saying, is the average USAFA height different than the average West Point height? Or another way of saying that is average USAFA height minus average West Point height equal to 0? And so this one is a little different because since I have two populations and two means, I have to take two samples. And for each sample, I have a standard deviation for each one and a different sample size. And so the way we calculate the standard error is a little different. And my estimate is no longer, before my estimate was, hey, what is my sample average height at USAFA? Now, since I'm interested in the difference between the means, my estimate is going to be the estimated difference. So it's going to be my estimated mean at USAFA minus my estimated mean at West Point. And that is my estimate that I then use to get my t-score test statistic, and then compare it to the t-distribution with pt again in order to get my p-value. But lessons 21 through 23 all were about doing tests on some type of averages of a numeric variable, and they all require using the finding a t-test statistic to use against a t-distribution in order to get my p-value. Russell, did you have a hand up, or did I answer what you were asking?
No, sir, I did have a question. So for the paired data, I know it's like we're taking the differences, but I'm looking at like the things we have to define for a hypothesis test specifically for the lab. How do we find like point estimates? Because like the homework, or not the homework, but the example you give for like lesson 18, like the for RStudio, I don't know how to translate that for GPAs.
If I remember correctly, was my example about the coffee and the heart rate?
It says low impact, high impact, $40,000, making less than 40,000 or making more.
So more that example about making more and less, if I remember correctly, that is the different. That is about the test for independence in two-way tables, I believe. If I mislabeled the lesson number on there, I apologize. But if you go down in that sounds like a problem about using chi-squared and testing for independence of, unless I am misremembering the example.
I'm just looking at both the slides and the example, and they kind of match up. Like it's asking for difference of proportions. Like you have to define null hypothesis.
Oh, okay. I'm sorry. So are you going back to talking about difference of proportions?
Yes.
Okay, I'm sorry. I thought your question was about paired data. And so I was saying, hey, that sounds like a difference of proportions. Okay, so I'm sorry. Switching gears. So you're talking.
I might be using the wrong information then. I think I got the P's mixed up. So would question 9 be paired data then? Or
yes, on the lab. Yes, that is. Yeah. So paired data, and so I'm actually going to just write it in here. So paired data is the same as we say, or mean of differences, right? We use paired data in order to do a mean of differences.
Okay, I just got the P words mixed up then.
No, that is a totally legit thing. I can't tell you how much of, and we're talking about mean of differences and differences of mean and differences of proportion. So that's why I'm trying to be as articulate as I can. Every time you see me look up, it's because I am making sure I am not tripping on my own tongue. Okay, and then the last one we did was sample size and power, right? And that one really had kind of three big concepts of it, right? One, it was just the general idea that when we do any of these tests, if we are thinking about before we do the test, we can control different things, but it's a trade-off. Is one, as we increase sample size, cost increases, or as we decrease this increases. And so we can't have everything, but we can decide ahead of time. If we know what we do care about, we can rearrange the equation to solve for it. And so one of the things we went into was saying, hey, if I'm doing a confidence interval, instead of just saying, here's all the information, do it, what's the margin of error? If we haven't done it before, I can say, well, I want my margin of error to be this number. Well, then I can rearrange everything in that margin of error equation to get n, the sample size, by itself on one side and solve for that and say, here is what my sample size has to be if you want that margin of error, right? And so I have a certain amount of control of manipulating stuff to decide ahead of time what kind of sample size I need to get the results I want. Yeah, I saw Kyler pop up and maybe someone else. What was the question?
Sir, on the practice GR for one of the questions, it had us get sample size and it only gave us margin of error and Z-score, I believe.
Okay, so, remind me of when I'm done let me finish summarizing this up and then tell me what number it is and I will bring that up and we can look at it together real fast.
All right, thanks, sir.
Definitely. And so the only last thing I wanted to say was the other thing from this lesson was the idea of power. So we talked about how to calculate it. We've got the steps for that, but that doesn't even matter if you don't understand, what the power of a test is, right? And so what the power is the more powerful a test is, the less likely we are to make a type 2 error, right? And type 2 error is when the null is wrong, but it is wrong by such a small amount that our test doesn't catch it, right? So when we usually talk about alpha. Alpha is the probability of type 1 error. And we like making alpha small because it reduces the chance of type 1 error. But that is sometimes is a problem if we don't think about power. We might be, if we are concerned about not rejecting the null hypothesis when the null really was wrong, we need to worry about power. And so we can talk about saying power is when we say, I want to make sure I can, my test catches this small of a difference. And that's when we start talking about power. And I can say the power of this test to detect that effect is a certain percentage. And the higher that percentage is, the less likely I am to make type 2 error. So that's what power is. The more powerful it is, the more likely I am to correctly reject the null hypothesis for those small differences. Okay, before I'm going to jump over to what Kyler was asking about, does anyone have any kind of big questions or things that you want me to reattack on that overview, or if there's anything I said that was confusing or that you think was flat out wrong?
So really quick, just so I'm understanding correctly, type 1 errors are errors in the data, and type 2 are errors in the reading or processing of the data? No.
That's a good question. So type 1 and type 2 errors are specifically about, because we have the null hypothesis, right? And the null hypothesis is either right or wrong. We will never know if it is right or wrong. We are just statisticians. So only God knows if it is right or wrong. All we are doing is doing a test to decide whether we think the null is right or wrong. And so sometimes we make a mistake. Sometimes we get it right. Type 1 and type 2 error are just about when we were wrong about the null hypothesis. So a type 1 error, so we never know, or at least very rarely do we know if we've made a type 1 or type 2 error, because the only way we could know for sure if we made that type of error is if we somehow, like if we're saying let's say my hypothesis was that the average height of cadets at the academy is 71.2 inches. I can run a hypothesis test and decide whether or not I reject that. The only way I would know if I made a type 1 or type 2 error is if someone, after I did my test, went and surveyed the entire population so they knew the exact actual answer, and then they could decide whether I made a type 1 or a type 2 error. Because a type 1 error means that I rejected the null hypothesis even though I should not have, meaning the null was true, but I said we should reject it. A type 2 error is when the opposite is true. Basically, I said, I can't reject the null hypothesis, when really the null was wrong and I should have rejected it. So that's what type 1 and type 2 error. It's when I choose to, that was the wrong choice. When we set alpha, alpha is the probability of type 1 error. So I can't know for sure if I made a type 1 error, but the smaller I make alpha, the harder it is to reject the null hypothesis, and therefore it's a smaller probability that I am rejecting it incorrectly. Beta is the probability of type 2 error. So, and power is 1 minus beta. So the smaller I make beta, the bigger the power is. So the greater the power is, the less the probability is that I make a type 2 error, meaning the smaller the probability is that I make the mistake of not rejecting the null hypothesis when I was actually supposed to. Does that make sense, or was that a lot of words without enough pictures?
I think that makes sense. Thank you, sir.
Definitely. Okay, I am going to try to jump over to the practice GR, so give me 1 second. Stop sharing, and then I'm going to share content. And where is my, let's not open the file that says Lab 7 Solutions. Let's open the one that says this one. All right, so What was the one that you had a question on? Do you remember what number it was?
Yes, sir. It was. Sorry, I scrolled past it again. I gotta find it.
No worries.
I think it's number 7.
Question
This one-
3 was the one that I was looking at.
And I realized it may be different on different people. So give me some words in it.
The superintendent of a school district wishes to take a poll.
I
month
got you.
before-
This one right here. It's number 4 for me.
Yes. So I got it right, and I understand the equation that I used, but I don't understand why the equation I used is right.
So what is? Let me real quick. Let me ask you what equation you used, just to make sure you are actually right and didn't just get monumentally lucky, because that actually happened on 1GR once several semesters ago, where we set up a problem where it turns out you could do it in a completely wrong way, but the way the numbers worked out, you actually got the right answer. So what did you do for this one?
So I had n equals z over margin of error squared times p hat times 1 minus p hat.
So you said n equals z over margin of error, that entire quantity squared,
Yes, sir.
and then times what?
Times p hat times 1 minus p hat. Where p hat was 0.5.
Superintendent wants to determine the chances of the proposed school bond receiving the majority of votes. She wants the margin of error to be less than 0.05. Okay, so to determine the chances. So this one, I will say, this comes from a previous semester where I would probably phrase this question slightly differently if I were writing it now, because this is making a few assumptions that you would have to pull apart on your own. One of them is the fact that you correctly surmised that it says she wants to know if the school bond is receiving the majority of votes, right? So that means she is working on the assumption that it is going to be centered around 0.5, right? And so you were, and that she then says she wants a 99% confidence interval, right? So in this case, the 99% confidence level gives you your Z star, right? Because when you do a confidence, because your margin of error is equal to well, in this case, because we are looking at a proportion, it's equal to Z star, right? So to find the Z star for 99%, that would be Q norm of 0.995. That would be your Z star. Then you would have to find your the margin of error is Z star times the standard error. And the standard error, like you said, is the square root of p hat times 1 minus p hat over the square root of n. N's the thing we don't know, right? So the first thing we do is we rearrange the equation to get n on one side. And that's how you got the equation that you had, and why you had a square on the other side, because you got n squared by itself on one side and then squared both sides. And that's why you got the squared on the Z star over the margin of error. And then the p hat times 1 minus p, that was originally under a square root. And so that's why it is no longer under a square root. And so then you just solve it out for the n. But like I said, if I was writing this question today, I would probably be more explicit about that she took a sample and that what her estimate was, because this question is saying, hey, she didn't say anything, so we will assume that the estimate is 0.5. And we talked more, we introduced it more like that a few semesters ago, but not this time. So yes, if this question had been given on a test, I probably would have told you that she took a sample and that she got an estimate of 0.5 that she's building her confidence interval around.
Okay, thanks, sir. Because what I had looked up was saying that it was finding the maximum sample size was using a p-hat of 0.5. And
Sure. And that's really what's happening here is basically saying, hey, this is a really what's happening here is that you don't know what p-hat is, and so p-hat can change from anything from 0.0001 up to 99.99, and so that p-hat times 1 minus p-hat can vary, but you can say the biggest it can get is when they are exact, when p is 0.5, because then you get 0.5 times 0.5, which is the biggest you can get it. As soon as it goes anywhere else, then it goes to like 0.4 and 0.6, which ends up giving you a number smaller than 0.5 times 0.5. So by picking 0.5, you are getting the absolute biggest number you can get there, so that you get the biggest necessary sample size. But again, that's not something we really focused in class, and so I would be more explicit about it or ask the question in a different way if I was putting a question like this on the test. But good on you for figuring that out.
Thanks, sir.
All right, anyone else have any specific questions in here that they came across, or any specific types of questions that you would like me to try to track down in here to try to see an example of something? Or if not, we can just go through with the time we have left and kind of look at what we have in here. I keep moving my phone because I'm thinking it's in my way, but then I forget that is how you guys are seeing me. And I'm super egotistical and assume that you guys can't learn math if you can't see my face. So I have to keep that on. Okay. Well, then please interrupt me if you see something that you have a question about, or if something pops in your head that you would like to, but I will jump through here and I will hit some. Yeah, Ryan, what do you got?
I think I'm still a little confused on how we're going about solving this problem. So this one would be
Tell you what,
like,
give me 1 second before you talk it out. Let me switch over to my OneNote, because I was doing a lot of stuff in the air. So before we get into it, let me write it so we can be looking at the same thing. So let me. There's no reason that the Academy should buy me this very nice touch screen if I don't actually use it. Well, they didn't actually buy it. So unlike you guys, I don't get to keep my computer. So let's, although from what I hear from you guys, none of you guys are super excited about keeping your amazing computers that you have. Okay, so using the example we had here, he said he wants to take a poll a month before the election. So they are looking at the margin of error for a 99% confidence interval, right? So if I have a 99% confidence interval, then I have this situation where we say, okay, to build a confidence interval for a proportion. So I'm going to say for a proportion, as I try to spell in public while making my handwriting not bad, can't do both. Then it's going to be, the equation for that is going to be my estimate plus or minus the margin of error, right? And the margin of error in this case is going to be, it is the Z star times the standard error. And the standard error in this case, because it is a proportion, is going to be the square root of p hat times 1 minus p hat all divided by n. Okay, so that is just how we did confidence intervals for proportions back in, I think it was lesson 16, right? So in the problem, though, it says she wants, it says it's a 99% confidence interval. Well, since it's a 99% confidence interval, that means that Z star is going to be Q norm of 0.995, which if I was a better teacher, I would know what that is off the top of my head, but I have not, I don't ever do things at the 99% confidence interval. Does someone have R open real fast that they can tell me what that actually is? All right, well, if someone can do Q norm of 0.995, let me know what it is. And I will continue until you guys tell me. So that's Z star. The question then says, she wants a
2.575829.
Say it one more time.
2.575829.
All right, I'm just going to say 2.57. Okay. All right. So that's my Z star. So then it says, hey, my margin of error, she wants it to be less than 0.04. So this right here is my margin of error. So I'm going to say 2.57, if I heard that correctly, times the square root of p hat times 1 minus p hat over n. That has to be less than 0.04. Well, then I can move this over to this side and square both sides, and I will get, what do I get here? I get p hat times 1 minus p hat is less than or equal to, I'm not going to try to do public math here. Doggone it. Sorry, I was trying to open up my calculator here and I accidentally opened up my command prompt. So if I go here and say 0.04 times 2.57, and I get 1,028. Someone check my math on that, but I get 1,028, and then I'm going to bring the n over here and the 1,028 back over here, and I am basically trying to solve for n. And the only thing that is stopping me from solving this, I think it was, I don't know who asked it. Was it Zane who asked this? I already lost track of who was asking. Is that we don't know what p hat is because she never took a sample. Oh, and someone just told me I have lost track. I forgot we started. We did not start on the hour like my other classes, so we are over time. So I did not mean to keep you guys. It is a short schedule calls. Do not let me keep you guys. I apologize profusely, but anyone who wants to stick on for a couple of minutes, if you got a burning question, I will stay around for a couple of minutes, but get out of here if you don't. Does that, Ryan, I know we're not done yet, but does that kind of explain where we were going there? No, Ryan, did I lose you?
So I had a quick question while we're, because I got to get to class. I changed my EI appointment for tomorrow because it wasn't really had to do with the test, but more so the lab. Would you still be available tomorrow?
I should be, yeah. And my session this afternoon can be about anything. I had too many requests I had to put up in that group. But if you prefer to do a one-on-one, I should start I'll start accepting for tomorrow. And unless it gets super crazy tomorrow, I'll still be doing normal ones tomorrow.
All right. Thank you, sir.
Yep.
And then I have one question, sir. Maybe a dumb question, but so for calculating